Hello students, I hope all of you will be fine. So this is our lecture on delta star circuits, that how to solve or find the required quantities in a circuit which are neither in series nor in parallel configuration. So this is one of the circuits like those configurations, because here you can see that here 100 ohm, 125 ohm, these are neither in series nor in parallel, because the two ends are neither connected to each other nor in series with each other. So what we have to do, we have to find the current and power supplied by the 40 volt source in the circuit shown here in this figure. So what we have to do, first of all, we have to find the equivalent resistance, and after finding the equivalent resistance, we have to go towards the current and power supplied by the circuit. So in first step, what we have to do, this is our circuit here. So in this circuit, this one is, these are our resistors which are given. Okay, this one, this one. Okay, these are our resistors. So this is 5 ohm, this is 100 ohm, this is 125 ohm, this is 25, this is 37.5, and similarly 40, and these are connected with a 40 volt source. So in order to find the equivalent resistance, we have to convert any of these two deltas. These two are basically the delta circuits, and converting any of these delta circuits into star configuration will basically make this circuit easier to solve. So the equivalent circuit will become like, you can see that here we will have this circuit, which is basically this series circuit, and A and 5 are in series, while this circuit, which is basically the series combination of resistor B and 40, these are again in series, while C and 37.5 are again in series, and the configuration of these two are basically in parallel. So converting them into some unambiguous form, it will become like this one. Okay, so here this is 5 ohm resistor, the resistor A is 50 ohm. Similarly, the value of resistor B is 10 ohm, and the resistor here is 40. The resistor here, now we have found out, is 12.5, which is the value of resistor C, and similarly this is 37.5. so the equivalent resistance is, okay, this one, this is here, and here this one, this one. These two are now in parallel, and the adding them together, because now these two are in series, these two are in series, and these two are again in series. And in series, we know that to find the equivalent resistance, the individual resistances are added. So here it will become 50 ohm, it again becomes 50 ohm, this is now 50, and this is 5 ohm. Okay, so let me go down. Let me go down here and solving it here. 40 volts. Okay, so this is now our equivalent circuit, where 80 ohm is our equivalent resistance. So now here we can easily find out the value of current which is flowing or provided by the 40 volt source. So that is basically, we can find it out by using the Ohm's law. So I is equal to V by R. V is 40 divided by 80, so it is now 0.5 amperes. Okay, so this is the current which is provided by the source. Similarly, the power provided by the 40 volt source is equal to I40 multiplied by 40, which is P is equal to IV. So by using the values here, 0.5 multiplied by 40, so this is now 20 watts. Okay, So this is the overall circuit, and the actual consideration behind solving the circuit like this one is to see that what are the configurations which are neither series nor in parallel combinations, and how to solve the circuits like those ones. So initially we have to find the equivalent resistance, pick any of the two deltas, or pick any one of the two deltas, or any of the stars, and convert them into the other configuration, and you will see that is basically our circuit. And here we have used the conventional circuit laws to find out the equivalent resistance, and after finding the equivalent resistance we find out the current and power supplied by the 40-volt source. So that's it for today, and we will solve more questions like this one in our upcoming videos. So thank you so much, and I'll see you soon.